Oh, sorry. We're on there. Oh man, I've watched some of these before. Watched myself, and it was very painful. I can't imagine what it's like for you all. But anyway, so here's a classic problem. It says a tow truck is pulling a car out of a ditch by means of a steel cable. So this is going to be a tension problem. But they tell us what the Young's modulus is in the steel cable, which is 2.0 times 10 to the negative 11 newtons per meter squared, um, which is basically telling us about how many newtons you need to apply per square meter to stretch that thing 1 meter. So that's a lot of force. But anyway, what is that is 8.36 meters long and has a radius of 0.44 centimeters. All right, when the car just begins to move, the tension in the cable is 850 newtons. How far was the cable stretched? The tricky part, okay, the tricky part of this, let me write down the data while I'm trying to talk here. So the force is 850 newtons. The Young's modulus is 2.0 times 10 to the 11 newtons per meter squared. And the cable is L naught is 8.36 meters. And the radius of the cable, so that which is part of what we need to find, um, is 0.44 centimeters. Okay, I think I've got all the information that we need to be able to solve this problem. We need to know how far it was stretched. And I think we've got it. So let's just write down the problem here real quick. It's F over, or the formula, F over A is equal to Y. So we've got F, we've got to find A. And this is always what, and you got to be careful because I noticed some students on the exam didn't read carefully, and it said the diameter of a wheel. That's just part of, that's kind of one of those separator type questions. Who's reading it carefully? Who's really at home, comfortable with the mathematics and things like that? R is equal to 0.444 centimeters. All right. And who's going too darn fast? Okay, is equal to delta L over L. So first, let's compute the area. So the area is going to be, uh, we got to change this to meters. So this would be 0.444 times 10 to the negative 2 meters. All right, and we're assuming it's a round cable. So the area is pi times 0.444 times 10 to the negative 2. I'm always leery of doing, I know you could just slide that over that way, squared. All right. Sometimes we're thinking so hard we forget to square it too. This is the hardest part of the entire problem now, is figuring out what that darn area is. So let's figure it out. So we've got second pi times, parentheses again, 0.444 second e to the negative 2 squared, close that parentheses, boom. I got 6.193 times 10 to the negative 5 meters squared. That's not a very big area. All right, so now we've got it. The rest of the problem is pretty easy. What we need is delta L, so we come up with FLOYA again. Yay. All right. So, and then you're done. All right. But this is the hardest part. You don't need to watch me punch in numbers on a calculator. All right. Out here, listen, and I'm gonna show you how to set up the next one.